All right, I think that it's time to start. Hello, everyone. You can turn on your video if you want to, so we can see everybody today. We are gonna have a webinar about machine learning, and my name is Oksana, and probably I was talking with some of you. I was calling you or texting you whenever. And Aka, he is a professor, so you can ask all the questions during the webinar. And how are you today? You can write down to our chat your name, where you from, and let's start our webinar. So let me introduce you to our school. It's Black Screen AI, a project of our IT school, programming in Silicon Valley. It's actually, this project is for English-speaking students. Our school it was founded in 2016 in California, and our school has a strong foundation. And years of experience in preparing students for successful IT careers. Let me check the chat, please. Hi, from New Jersey. So I have no video. Okay, hello, this is Savannah from Florida. Hello, hello from Florida too. All right, from Alabama. All right, thank you for spending this evening with us. Our instructors and assistants work in companies in the USA, Canada, and Europe, and programs are developed considering the requirements and processes of IT corporations and startups. And by the way, our school, it was founded in 2016, we mostly had Russian-speaking students. But after graduation from our school, they started working in American companies. So we decided to make this project like for English-speaking students, like people, because why only Russian-speaking can use these opportunities? I think that we thought that it's a wonderful idea to have this, to give this knowledges to you. And our programs are developed considering the requirements and processes of IT corporation and startups, as I said. And students undergo internships on commercial projects, and we'll talk about this a little bit later. So our goal also not to give you like really important knowledges, but also to help to reach employment. And while I am talking about our school, our program, tell me more about your experience in IT. Are you already in IT, or are you planning to start being IT specialist? Tell us more. I think that it would be also interesting for Aka too. And as you see on this slide, it's our journey since 2016. This collage represents a vibrant community and dynamic journey of our school. Please turn on the microphone. Let me do this, because every noise, it's like could interrupt listening. So as you can see, our students and instructors are engaged.
I'm surprised that you were here.
Engaged in various activities, from classroom learning to outdoor events, fostering both technical skills and strong connections. And by the way, our school, it was when it was founded, it was offline school. So we had to leave classes, but now we mostly online, but we have some adventures together, not just like we don't just give remote jobs and remote opportunities. We also give some brilliant, wonderful journeys together. All right, and let me. So we also have a lot of reviews from our graduates. People graduated from DevOps online courses, from like full stack engineer. So most of them found really good jobs in such companies as Microsoft, Oracle, Tesla, and like as you can see, like there are a lot of famous, like well-known companies. Let me check the chat. New Jersey, can you see? Dallas, California, Florida, Chicago, Florida. So Maryland beginner. Okay, waiting for all the answers too, because if you just joined, tell us more about yourself, about your experience. And are you already in IT, or are you going to, and today's first day, we have 2 live classes. Today it's our first day, and we're going to talk about what is machine learning and how does it work.
Birthday bad. It will.
Turn off the microphones. Okay. How does it? A comprehensive beginner's guide. We'll talk about this. Let me check. I think Echo, it will be also useful for you to know if our listeners, beginners, or so we mostly see that people are beginners. So don't be too strict, and don't use too difficult words for all of us, please.
Sure, no worries.
So, and we're going to talk about machine learning today. And what is this? We're going to Aka will explain you more about machine learning, how it's transforming to a global economy with the market size valued as $8.43 billion in 2021. And how it's expected to grow. And as you see on this slide on our presentation, that by 2030, the market is projected to reach 209.991 billion by 2030. So it's kind of huge growth. So it's gonna be like one of the fastest growing and most in demand fields worldwide. And here you also can see that 76% of companies priorities sorry about this, AI and ML over the other IT initiatives in 2023. 47% of digitally mature organizations have a defined AI ML strategy in place, and 64% of businesses report using ML in some form, with the highest adoption rates in the tech, finance, and healthcare sectors. And let me introduce our instructor, and his name is Eka Dari. Hold on, please. Please turn off the microphones when you join. And as you can see, Ako is AI expert and data scientist with over 7 years of experience in machine learning, deep learning, and natural language processing, including work with large language models like BERT and GPT-4, former PhD student at George Mason University. So he's also a student like you are. So worked on project funded by NASA, then slowly combined its daily usage of big data and advanced statistics with statistical learning at machine learning. developed advanced ML and DL models and geospatial analysis time series forecasting and financial modeling. Proficient in Python. Actually, we are going to talk about Python 2, and we are going to talk why it's important too for studying machine learning and building end-to-end data pipelines and deploying models into production. So, Akko, tell us more about yourself and tell us more about machine learning.
Sure. Hello, everyone, and thanks for joining. I'm happy to be here. So I will try to give you a short summary, and then we'll not dive that much to the detail. For those who are more experts, pardon me on that part, but we'll try to get an idea of what is machine learning, what is AI, and also what is not machine learning. And then I will be happy to answer your question at the end. So next slide, please. Sure. So before diving further, let's think about two distinct phenomena. Let's say we have 1 billion transaction. Just recording that 1 billion transaction in a book, reading them is a huge, huge time investment. Imagine in the old days, people had to really write them down in paper. Now we can do a lot of this repetitive work by computers, and they're extremely good at doing what exactly we tell them. So we can have 1 billion transaction or 100 or 1 million. It doesn't matter. If you tell the computer what to do, it will do it for you, right? But also there are new concept or new paradigm in computer programming that we will dive into that further, which we can call it machine learning. So, and before also going further, we can see that there are a lot of application, like healthcare, climate science, finance, you name it. There are a lot of different applications. So now we can get an idea what is this computer programming is gonna do. And now we go to the next slide, and let's start with the basic. So one slide back, please. Thank you. So let's start with a very basic question. What is AI? What is ML? What is AI and what is not AI? One example that I generally use is when we talk about AI, one of the things that come to mind is like Terminator. Some machine or robots come from the future and they're trying to wipe out humanity. So what we are talking about is not that. We can leave the science fiction alone side and then just talk about what is it going on right now and also how we see it going on in the future. So in a very, very simplistic way, we can say we have some data. We feed those data to something called algorithm. We can come back to that. And then we quote unquote train a model and then we ask the model. So let's go to the next slide and go a bit to the side. Let's say, for example, in the past, I could have write a program and said, okay, whenever a user is clicking on this button, open a web page for me. Sounds easy, right? Or if someone asks for a calculator and asks like, what is 3 plus 5? You calculate it and you give the result. In this way, we are telling the computer exactly what is the input, how to do it, and the computer calculates it and give us the output. And a lot of what we have built from 1950 all the way to 1990 and 2000, 2010 even, was generally by this strict rule. We can think about, yeah, I think it's a good idea to maximize the slide if we can. So, but let's say now I want to write a program that if I show it two images, one is for cat and one is for dog, how my machine can distinguish them. Let's think about it. So what are the difference between cat and dog? You can write it down in the chat. For example, we can try to describe, okay, these are the characteristic of a cat, these are the characteristic of the dog, these are the specialty. But you can imagine it's really, really difficult. And then let's say the cats could be different color in the different background, in different shape. And the same will be for dog. And we can imagine that this is extremely complicated. Now we go to a new paradigm, which is machine learning. The exact or one of the oldest and well accepted description is when we program the machine what to do without explicitly telling it what to do. So what does it mean? It means that I can write an algorithm based on statistical learning, show the machine 1,000 or 1 million image of cat, 1 million image of the dog, and let the machine, quote unquote, learn. After the machine learned, I can ask it, show it new images of those cats and dogs that the machine has not seen, and ask it, is it a cat or is it a dog? So that is the basic idea. I hope it makes sense. So in a sense, we show enough data to the machine, and we are hoping by providing clean data with feature extraction and other techniques, the model will learn the essence of that and then can tell us about the data it has not seen. So what it is good for? What's the advantage? One example is probably you can remember from early or mid 2010, if you are uploading a photo to Facebook, it was saying, oh, is that you? Is that your friend? Is this your brother? It's hard to imagine that like someone writes a code to distinguish 1 billion people. But with those model being trained by the images, then Facebook was able to suggest those images, right? We are going to the realm of image analysis. One other thing might be for YouTube. When we watch a YouTube video, then we can see, oh, the algorithm will give us different recommendation. Do you like to see this video or this video? I see a good question by Kumar, right? Which algorithm to use? Sure. So the base of them are, in a broader term, based on machine learning. We will go to that further. So let's just brainstorm. For Netflix, we have the case that, oh, maybe you like this series. When you go to Amazon, it says, oh, you bought this one, maybe you are interested in this one. So we see different algorithms playing a role in different industries, right? So I think you can see the machine learning, but let's go to the next slide. Okay, so we can think of a big umbrella and we can call it artificial intelligence. There are a lot of philosophical or academic debate of what is intelligence and what is not. And is the intelligence only what humans have? For example, a squirrel can hide nuts in a square, in a hole, and like come back next year and exactly find it, even not like half a meter to the left or right. Is that sort of intelligence? Because a lot of us can forget where did we put our phone and look for that, right? So, but in general, we can say, okay, if a machine or a device can have sort of intelligence, we will call it artificial intelligence. And while we see a lot of boom about that, we can trace it back to 1960s or 1970s that there was a possibility, and a lot of people were saying that we can train a machine to do things, but we didn't have enough data and we didn't have computational resources that we have. So it went to a cold freeze for like almost 3 decades, this idea of machine learning. But then it got a boom and now we see that it's everywhere. One also clarification thing is a lot of people, even in the organization, in the VP of data science, you can see that they make a mistake or they use them interchangeably. The broadest skill set, the broadest domain inside artificial intelligence is machine learning, but artificial intelligence is not only limited to machine learning. There are other areas. but we will stop here. I think we don't want to go deeper. The broadest class under artificial intelligence is called machine learning. We describe machine learning. We teach a machine, in this case, a computer, to do things without telling it what exactly it is. One example was to classify image of cat and dog, but also we can think about it that it can predict the future or it can predict the past because it is learning their capacity. So there are possibility for that. Okay, for the next items, I'm just giving you a short overview. You don't have to remember it or memorize it. Just remember the broadest set is artificial intelligence. And then the biggest player in the artificial intelligence is domain. And now we go a little bit deeper, but they are just for information. Sometimes there are problems that could not be solved by machine learning. So we go to deep learning or deep neural network or different naming. So we are trying to make it simple. Pardon me if I'm not using the exact technical word. We can agree that we can call this deep learning. We can call it artificial neural network and many other names. But yes, so deep learning can do much more complex things that machine learning cannot do. And when we go to the technical detail, we can make a distinguish between this one. One subclass of deep learning, because we have vision, image, video, and many things, is generative AI. If you were in the market, you will remember around 2018, 19, there was some images, some apps that you would have upload your image. It was showing you if you are younger, if you are older, how do you like that? How were you look like? It was part of the earlier adoption of generative AI.
But no,
But
I'm not brown nosing.
okay, but it was a little different. It was called adversarial network. We don't go that. But so we had generative AI, meaning that in a loose term, the machine can generate something. It was in the market and the academic and tech industry were excited about it, but it wasn't like that much into the people outside the world. And then a subclass of this generative AI is LLM, which stands for large language model. Again, we can talk what is large. A model that today is like in 2025, a small model by Microsoft only has 4 billion parameters. 2 years ago, it was a big model. 4 years ago, it was unimaginable. So these terms are up to discussion, but we can agree, okay, we have large language model. And the one that got the world by storm was generative pre-trained transformer or GPT. When GPT-4 came to the market, it changed everyone's perception about AI capabilities. And we see that in the last 2 years, a lot of businesses have evolved and trying to use that and adapt it. And it's a good news for us because, as we saw, there is a huge demand for artificial intelligence skills. And not everyone should be a coder. You might be a business decision maker or manager, but knowing what is AI could help you make better decisions. So what we see here, as we called, we have GPT. We have also other versions of this LLM, which can talk. We can talk about the image or vision. One famous example was Stable Diffusion. You were typing something and it was trying to create an image for you. So we can talk about that. More and more, we are seeing also development in text to video, which is interesting, and also video to text. So there are a lot of applications, but just remember the big picture. We are really going to one of the branches beneath. It has a boom. Half a decade ago, it was computer vision. For some people, it might be voice. For some other people, there might be other applications. But at the moment in 2025, we like it or not, there is a lot of hype and excitement and funding and possibility about these large language models. So I hope that is good enough. we can come back and I would be happy to answer your question, but I was trying to give you a brief overview of this terminology. We can go to the next slide, please. So when we are talking about algorithm, we can go to the more detail of that, but we can think about an algorithm in a little different way. If we can go back to some basic mathematics, let's go back really simple. If I ask you what is, let's say, 4 plus 6, we all know it is 10. And if we say, okay, what is 10 minus 6? We know it's 4. What is 10 minus 4? It is 6. Now we can generalize this and say, okay, A plus B equals C. And we can call it a linear line. Let's say we have a lot of dots and we want to try find a line that best matches these dots. We can think about it as what is called in statistics regression. Okay, it could be for house price, it could be for climate application or many other applications. Now, rather than having the input and the equation and asking the machine, give me the output, here we do a paradigm shift. We give the model the input and the output, and we ask the model find the best equations. And this is fundamentally different. It is really important. If we get to this idea, then we can make sense of a lot of other terms that we hear about minimization, penalizing, and many other things. But the idea is we have the data. In this case, we have cat, dog, images. And we have the output, and we want the model to find that. That is the idea. And how we can find it can find that it is different tools that as a machine learning engineer will have in your toolbox to use. For a lot of simpler model, and simple doesn't mean easy. For a lot of simple model, we can use machine learning models. Example of that is linear regression, random forest, decision tree, extreme gradient boost, and many other applications. Sometimes we need to go to deep learning models. For example, for image and video, we may need to use, in majority of the case, we need to use deep learning models. And there are different deep learning models like convolutional neural network or recurrent neural network and many other things. One type of that deep learning is transformers. And these transformers, AKA attention mechanism, was what led to this huge boom in ChatGPT. The T in ChatGPT stands for transformer. We talked about generative. We know what is generative. So GPT, G stands for generative. Pre-trained means that the model has been trained based on the entire data, and transformer, it used a transformer mechanism to give a result. I hope that is good enough. We can talk more about the details. Just one example is also reinforcement learning that really improved the capabilities of a lot of this deep learning, but we don't go there because it might be a bit too much. So you can read that excuse me. You can read that, the notation. I think it's very clear. One simple example is like predicting the stock market or predicting the weather. We might make an assumption that a model could make this prediction to some degrees.
Go back in time. No.
And just one important thing is a lot of this machine learning, deep learning models, and a lot of this GPT, they are non-deterministic. It means that they will always have an error. Even if their accuracy is 99% or 99.99, there is still a chance that they may be wrong. That is important for us as humans, for our society, to make sure that not whatever we see from a model or chatbot is always correct. And also that is important that we should have mechanism to check them. Okay. Okay, let's go to the next slide. And I see again request to make these slides maximize. If you can do that, I think on your Zoom, you can make the slide maximize. I cannot do it from here because I'm not a host, but if that can help. Okay, now if we agree that we have sort of understanding what is this machine learning, we will use machine learning here, but we know that sometimes they are interchangeably used, although we know there are clear definition between them. We can think about some of the application. For example, in finance, one of the first companies that I worked for was a small startup. It was built in France by a professor and his top 3 students. They were very successful. They came to US and they were merged to MasterCard later on. Their significant product was credit card fraud detection. I assume majority of us have credit cards, and there are 2 types, twice that our credit card might be rejected. Let's say I live in California. For some reason, I have a
took swabs of a shopping cart handle before and after wiping them down with a sanitizing wipe that's available at most stores.
Hey, Roy, could you
Okay.
please turn off?
Sure.
Thank you.
Let's say I have unexpected plan. I am in Nebraska and I swipe my card. What will happen? Probably my credit card will be declined. Why? Because the machine says, hey, this guy was in another location. There is another location, and so it is probably a fraud. In this case, the model was wrong. It was logically me, because I know it's me. But it was reasonable for the model that think that something is irregular in this pattern and decline that. If we want to be more specific, we can say that it was false negative. Another example is someone steal my credit card and make a purchase while he is in South Africa. The model will decline it, but this time it is correct because it was not me. And when I think about myself, I might have 3 or 4 credit cards and I might have like 100 transaction per month. But again, when we scale that to billions of transactions, then we see that we really need an important model. We need a strong model to be very accurate and also very fast, because we don't want to swipe our credit card and wait there for 5 minutes, right? Every decision is made in seconds. There are also possible, one other famous thing that we will hear about it a lot, and in this case, a bit difficult to discriminate between hypes and what is really happening, is with hedge fund and letting the bots means that like human is not doing it, some sort of trading. That is a possibility, but it has a lot of issues. But again, with fraud detection, with anomaly detection, with way abuse, and with trading, there are possibility for data scientists and machine learning to work in finance, and there's a demand for that. Next slide, please.
Hello. Bye.
Okay, so we see that, I think it's just summarize what we're talking about. Okay, so as I mentioned, one of them could be algorithmic trading. Also, sometimes when we apply for a loan, a machine can make a decision or give a recommendation to decision maker whether this person has a high chance of defaulting on the loan or no. So a lot of the banks and financial institutions are looking for different people with data analysis, data science, and machine learning skills. Okay, a lot of hedge funds are also working on that. And I'm a bit hesitant to say it is 100% machine learning because there are a lot of nuance here, but as a general rule, we can say algorithmic trading is a powerful tool and it's being used by a lot of hedge funds at the moment that we are speaking. Okay, We can go to the next slide. Again, with this boom of LLM, there are multiple initiatives. One of the famous one was by JP Morgan Chase, that it was trying to build a chatbot, and this chatbot again is powered by one of these LLMs, and it was trying to communicate with the users and give them advice. Again, because these are non-deterministic, it is important that it should not be the final decision maker. But in terms of doing the research, making some recommendation, they are very important, very helpful if it's been used correctly. And a lot of startup and well-established companies are using them as a advisor. Okay, next one, please. We talked about the fraud detection. This one is notoriously difficult. And let me tell you a little bit more about it. We have time. Here, in this specific case, we are talking about anomalies. If we go back to our example, we talked about like 1 billion transaction. In 1 billion transaction, we might have 0.2% fraudulent data. And if you give this to a newcomer, someone who doesn't have the basic understanding of mathematics and doesn't know how the machine learning works, may just throw a strong model. That model does it best. But you know what will happen? Let's say I have 100 transaction or 1,000 transaction, only one of them is fraudulent. If my model says that all 1,000 transactions are legit, then it has an accuracy of 99.9%. But is it a good model? Probably not. And it is one of the good examples that we need some sort of understanding to see what are we using, what tools we are using, and when to use which tools. Okay, next one, please. I understand this might be a bit complicated, but bear with me. I'm just trying to give some examples. I hope that it will make you more curious, and then you will find your interest and you can follow up on that. One of the other examples is sentiment analysis, and sentiment analysis in financial sector, along with many other sectors, could. Okay, I appreciate the joke. I will try to make it simple, but let's say I have let me make an example. Let's say I have an online market and I sell something on Amazon. And let's say I get 100 feedback from customers. It might be difficult to read all 100 comments from all the users, but we can write a model that look at all those 100 comments and tell me if the feedback was positive or negative. As simple as that. Okay, we can call this simple sentiment analysis. Next one, please. I talked about stock prediction. It is a very complex one, but I made an example about JP Morgan, but also Bloomberg did something very interesting. They call it Bloomberg GPT or Finance GPT, that they had massive amount of data. They trained their model on that and they are selling it. So it has those capabilities to get ideas from the news, use the sentiment analysis that we talked about, and make a prediction. Is this news going to impact this stock, yes or no, with many other statistical analysis, and then help to make a better prediction for the stock price. Next one, please. This is a correlation matrix. It will tell you which variable are more related to each other. Just let me tell a simple example. Let's say in the summer, people are buying more ice cream. And let's say in a same city, just an accident, more people are committing crime in the summer. In this case, the selling of ice cream has a correlation with more crime. Can we conclude that, oh, so more ice cream sales leads to more crime? The answer is obviously not. They just happen to happen in the same time. So again, it goes back to the one of the topics that, okay, having some good basic understanding can help us. It is a visualization tool. It can make us make some good guess, but we cannot make a judgment on that. Next one, please. Okay, so more and more we are talking about finance. In the world of finance, there are a lot of hype and potential to build a model that could predict stock price. Let's zoom out for a moment from stock price and think about crypto. Crypto is extremely volatile market. It goes up and down in a way that is difficult for a human to understand. But if we have a good bot or good algorithm that can understand the historic data, get good trend, and being trained on the well data, the data quality is very important. And then we have different checks and balance, meaning that we monitor the model, then we can have that bot to do some sort of real trading or mimic the trading, and then it could be useful. So we see there are a lot of applications depending on the domain that we're working on. Next one, please. Okay, so there are different ways to talk about machine learning. Before going here, let me just give another example in another domain. Probably many of us have had some sort of X-ray. There are thousands of X-ray that radiologists should go over all of them, and a lot of them are not visible by eye. But Google has shown by training a model, they could first be 70 or 80% right. At some point, they got an expertise of a human expert level. Now they are surpassing the human level. So we can think about it in terms of money, but in terms of like helping humans. If we can find these tumors ahead of time and alert the doctors, we have the potential to save lives, or at least reduce the risk significantly. The same goes for a lot of environmental issues. And so there are different examples. It's not only about finance, but we see healthcare has been suffering a lot. It is very old school, bureaucratic domain, but there are promises that healthcare can be helpful. Again, we are not thinking that AI can do everything, but we do not throw it away out of window that's useless. We know that there are possibility for good use of machine learning models to help us. Okay, so now we can talk about general type of machine learning. There are generally two types of learning, supervised learning and unsupervised learning. All the thing that we have talked about is supervised learning. What does it mean? It means that if we go back to the example of cat and dog, I was showing the model and I was saying, okay, this is cat and this is dog. In another word, we can say those data were labeled. It was a label. These are different animals. Look at them and learn their characters, right? It's an example of supervised learning. And I could easily say 80 or 90% of the application that you see in your day-to-day job is generally supervised learning. But there is another way that is unsupervised learning. This one has potential, but it hasn't been fully used as widely as supervised learning. In this case, I have some data, but I don't know what's going on. I give it to the model and I ask the model to find those who are more similar to each other. One example will be clustering. Let's say I have a city. I have different blocks of the city, but I don't know how this city is connected together. If we give it to the model can make different clusters and let's say label it for us that, okay, this is a business district, this is a residential district, this is more like military district, this is more like tourist district. So there is a potential for models to also help us in unsupervised way. There are two other categories, but they are a bit complex, so I will stop it here. Okay, next one, please. Okay, one good example. Let's say we are trying to build a model that categorize emails as spam and not spam. How do we do that? We might have 1,000 or 1 million example of spams, show that to the email, show that to the algorithm, and then algorithm will learn that, okay, based on different characters, like the subject line, the sender's email address, the content, and many other things, are they spam or no? And again, they are not 100% right, but we can achieve something like 98 or 99% accuracy, and this is good enough. If we want to be a bit more creative, we can think about two possible ways the model that can make a mistake. What are the pitfalls that my spam detection model can make? One example would be that there's a spam email and my machine doesn't catch that and it shows in my inbox, which is okay. People can like ignore that. The other one that could be a bit annoying is if an email that I'm looking for and it's important, I don't see that. Generally, they tell us, okay, if you don't see it, go to your spam folder, right? In this case, the model made a mistake and labeled an email, which was not spam, as a spam. Having these rare examples in mind can help us to better look at the models, know about their shortcomings, and then when we want to make a business decision or advocate for a model or speak in a like community or in a job market, we can show that we have more understanding of the shortcoming of these models. Okay, next one, please. Okay, this one is a bit more to the detail. It's okay if you don't follow, but let me just mention that briefly. When we are talking about supervised learning, generally we talk about two types of model. One is called classification, one is called regression. Classification goes back to that cat and dog. Is this image cat or a dog? We are here having a classified model. Another one is like disease or no disease for a like healthcare application, or the simple one like red or blue. The other one is regression. Regression means that we are trying to come up with a numeric value. Let's say I have a database of Boston. I have some characters of the houses, like how many bedrooms do they have, which year they were built. And then I have enough data. I train my model. Now there's a house in the market. This time my model can give me a good estimate of the dollar amount for that value, for that property. We see that in, I'm trying to learn Zillow, right? Zillow also using that for rent estimate and property value. It's not always accurate, but it gives us a good number, and we can think about of it as regression. Here we have examples of dollars or weight or time. Okay, so we have an idea of what is regression, what is classification, and they are both types of supervised learning. Next one, please. Okay, this is a good example. We have some dots and we are trying to predict a line that will have the minimum error. This is a try and error, but okay, it's a good example with what we had for those house prices. You can see it, it's very clear, and it's a very simple yet powerful solution for a machine learning model. Okay, next one. And this one is a good example of unsupervised learning. We have quote unquote unlabeled data. Contrary to the previous example that we knew exactly what is in each image, here we don't know. We give it to the model and the model try to group them by clustering or by making an association between them. I think it's clear enough, so we can go to the next item. Okay, this one is a cute and good example of k-means. Again, there are different ways to think about it, but we can think about different zone in a city and we can cluster them and say, okay, these are the cluster with the most similar characteristic to each other. And this one is very good example. This simple example was one of the early examples that the model was failed to do this. And this was one of the reason that we went to that cold or winter period of machine learning because it was failing to do something as simple as that. Okay. Next one, please. Okay, so in short, I tried and I hope you have come to this conclusion. I tried to give you a very simple example of what is machine learning. There are numerous ways that machine learning could be used in many different industries. And a lot of companies from very small startups to huge Fortune 100 companies, if not all of them, majority of them have different data science, data analytics, and machine learning teams. And there is a lot of opportunity for a lot of people about this. I just want to make two clarification, and then I will give it back to Irina to continue. I will be here to answer your question. So just what is the difference between data analyst, data scientist, data engineer, machine learning engineers? There is no clear scientific distinction between them, but as a rule of thumb, based on my experience, this is how I define that. Data analyst generally is someone who can do a lot of statistical analysis, and also they are very comfortable writing different SQL queries, but they generally don't have the skills of machine learning or modeling. This is what we can call a data analyst. Data engineer, which is a strong domain, is for people to build the infrastructure behind the scene for data scientists to do their work. Meaning that, let's say I have a company that has 1 million data points from the customers. Those data are not ready to be used by machine learning models. So there are different infrastructure that will collect all of this data, clean them, label them, and send them to the model. This is data engineer team. Data scientist generally is someone that is expert in different machine learning and deep learning models. What we talked about was generally about the core of what a data scientist will do. In a nutshell, data scientist knows some basic mathematics at the level of high school algebra and calculus. You don't even have to go deep, just having some knowledge of them will be good. Knows some levels of computer programming. You are not going to be a back-end or front-end developer. You are not going to be a hacker, but you can talk to a computer to train a model, test the model for you, and some domain knowledge. And this is good for people that, let's say, you are working in a bank and you want to get a raise. Because you have good knowledge of that domain, then you can be a good data scientist because you have expertise in that domain. Same goes for the agriculture and healthcare and finance and many other things. And then machine learning engineer. This part is more about an end-to-end solution, meaning that after this model has been built by data scientists, in the past, they were handing it to the data engineer to put it in quote unquote production, meaning that it was in the whole backend infrastructure system. A machine learning engineer is someone who knows a lot of data scientists, but also has some expertise in computer softwares to build the production-ready machine learning model. So deploy the model, monitor its performance, and if it needed, train it again. And machine learning is really important role, and we see the demand for that is growing more and more. One final note would be like, why Python? And probably you heard about it. There are a lot of opinions, but in general, we can say that there are two reasons that why Python is so popular. Number one, it is significantly easier to learn compared to many other well-established languages like C and Java. Also, majority of the machine learning models either native Python or they have API, or let's say the way that talk to Python. So by learning Python, we can learn about the way to talk to a computer, learning about how computer works. And then we have vast amount of tools at our disposal to use for different business problems that we are trying to solve. With that, I would like to give it back to Irina, and I'll be here to answer your question at the end. Thank you, everyone.
Hi, Dan. Thank you for giving us all this information. So in general, why should you start with this field? Because it's because like Akko mentioned, like a lot of like a few of fields in IT, and it's one of the most in demand and high paying fields in IT. So in just 6 months, you can start working at an IT company and start earning up to $100,000 per year. And we will tell you why. We made some research and how much do machine learning engineers earn. So junior up to 12 months start earning $110,000 a year. So you can see if you, I saw that there are a lot of beginners, and I also will like calling a lot of you guys, and I know exactly that this is a good start, like if your IT career, and as soon as you start working, you already become earning good money. And for example, we made, as I said, like we made some research, and usually people like companies, they the average salary is $161,000 per year, dollars per year. So, and let me tell you more about in details about our course. So you will learn how to work with various machine learning algorithms, about data processing techniques, build predictive models, practical application. And I saw a lot of questions in this chat, and a lot of you guys asked about presentation. You will get the presentation and recorded this recorded lesson. And don't forget that tomorrow will be the second lesson, and you will find out more information too. And let me also tell you more about our course. So we not just help you to gain really important knowledges about machine learning. We also help you to build your resume. We also provide you with career coaching, so you will participate in mock interviews and receive personalized feedback to improve your technical and behavioral interview skills, what is actually crucially important. And we also help you to build your personal job search strategy. So since you start learning on our course, you will start also building your personal search strategy, job search strategy with our specialists. And let me also tell you about timeline of our activities. The course starts February 3rd. It will be a 6-month journey towards a successful career in machine learning. So you'll also participate in live sessions 3 times a week. It's also important to know that you will have 3 live sessions a week, but we know that most of you guys working, so all of our lessons will be recorded, and you will also have a lot of practice. And one of our really important things that our school has, it's internship. Will we create project for portfolio? Yes, you will create project for portfolio. What type of problem a junior would solve versus a senior? I think that this is question for Ako, and we have give me a couple more words about the course, and Ako will answer you, because I see that there are some questions that Ako can answer them. So, and you will also improve your online presence and prepare for upcoming job interviews. So how it usually works. So we have a career coaching on our course. So as I said, you will have your own project, you will have internship, and you will be preparing for the job interview. And our internship training program, you will get introduction to data science, linear regression, and introduction to Sklearn library, introduction to machine learning. So all of this, classification, tree-based methods, and everything, you will get the presentation. So you will find out more about this too. And so you will find out everything you need in this training program. And as for the price, it's important thing, if you're going to start learning on machine learning, you have to basically have Python base. So if you don't have, we have a course. It costs $999. It's perfect for beginners if it's your first step into programming. So if you're gonna start learning as a machine learning course, and you haven't done Python before, you have to start with Python, and then you can go and start learning machine learning. And the full course costs $12,000, but the first part you will pay, it costs $6,999, and the second payment, it's learn risk-free and focus on your skills while we help you succeed in machine learning. So the rest of the amount you will pay only when you secure your job. So you won't risk, you will get your own knowledges, and the remaining amount you will pay just as soon as you find a job. And if you want to join our course right now, we have limited offer, and our group is also will be limited, so we don't want to have more than 30 students in the class. So our price right now, it's $5,999. And you can scan this QR code, and you can log in the discount for $49 right now. And so we will contact you, and you will ask more questions, or you can make a payment for the full amount right now, or you also, if you have any questions about installment payment, you can scan this QR code. So you will get a consultation from our team. And let me look at the questions. Let's do 999 better for beginner, makes sense. If you want to start, it's a good start to start with Python, a language. So you also can follow this link, this QR code, and we will also provide you all the information about how to get that course too. So I answered about the creating project for portfolio. Yes, we do this. And I see that Aka answered you what type of problem a junior would solve versus a senior machine learning engineer. It depends, but so Aka is already answered. How will identify which algo will use in your example? I see that Irina answered on this question. I'm not sure if, yes, Ako is also answered. Okay, let's look at the new questions. Okay. Real project in your portfolio with Google. All right. And let me also answer like on the frequently asked questions. So the course will start February 3rd, 2025 this year. It's how long is the course? It's 6 months. It will be 3 times a week. Usually one class is late for 1 hour. What is the course schedule, and what if I won't be able to attend live classes? All our classes live, as I said, but we always post a recording right after the end. It's not required for you to attend live classes because we know that most of you are working, but it's on you to watch the recording and do homework too. What's included is job assistance. It's mentoring sessions, mock interviews, interview coaching, resume building. Please stop doing this with our screen. All right, so will we have any real experience in our resume at the end of the course? So yes, all projects you will practice on will go towards your job experience. As I said before, as I mentioned before, so you will have your project done on the course, and you will also have internship. Basically, internship is one of the most useful practice part of the course, because somebody of you mentioned on our chat that you can find all this information on Google for free, but of course we can all the information find on the Google, but what about your experience? And we can help you. We will provide you this experience to you. So you will have the opportunity not only get the knowledges that you can find on Google, but you can also practice and get experience from internship with us. And if somebody of you just joined, I will also answer you that Yes, so during the course, you will start the project. Yeah, Irina is right. And so again, if you're just joined, you will get the recording on your email too. It's a frequently asked question today. And you can lock in the discount for $49 today because the regular price is $6,999. And today you will pay $5,999 instead. And you can lock this price just by paying $49 right now. Let me check our chat. So yeah, during the course, you will start a project, and project is where you'll take tasks and work on them if they're your real world assignments. They got me on internship. Join us and you will get internship with us. You will make your own project and you finally can start working and earning good money as machine learning engineers. Okay. If you have more questions, so you can ask them. You can also turn on your screen. You can ask a question. You can turn on the microphone and we can discuss if you have some specific question, because as I see, Aka and Irina answered all your questions. So the course starts February 3rd. What else? Okay, I think that we answered all the questions. So again, as the course starts February 3rd, you will get internship, you will get practice, you will participate in live sessions. Our specialist, our career coach will help you to build your resume and help you to prepare for interviews, to prepare your we will provide you the project, and Ako has a question or answer.
Answer, yes. So I was just gonna say that is correct that there are a lot of information on the web that are for free, but just one example from Coursera. The study by Coursera, and it's been confirmed by many other online institutes, more than 80% of the courses that people are starting online, they will never finish it. So yes, there are a lot of courses available online. There are books, but the point is here, you will first of all commit yourself to finish that course. You will be in a community of other learners. You have the opportunity to talk with a human being and get a real feedback. And so I understand it's not a cheap offer, it is expensive, but I think the side of that you are enforcing yourself to spend 6 months to really work on this, build a portfolio and get a real experience from the other people. This is really helpful. But again, it may not be for everyone and there might be some financial difficulty. I understand that. But again, when you have a dedicated course designed from the beginning to the end that will accelerate your journey from like something that can take years to 6 months focus work. And also a lot of companies are saying in their ads, you can go and search for cybersecurity and for artificial intelligence. If you have good enough experience, then they might even waive the degree requirements. So that's also one opportunity. And when you are working with some other fellows and you have a professor, you learn how to build your GitHub profile, what to do on Kaggle. And a lot of people that I have seen without degree, even abroad, they have got good offers because of their portfolio. So I think it's also important to mention that.
Yes, thank you so much. Ako, there was a question about you said the course is 6 months. Does this course offer financing or is it all in one payment. So yeah, we have option. If you want, yeah, you can pay in installments with Klarna. So you can scan this QR code, and we can, if you want to pay by installments, you can scan this QR code. So we will guide you how you can pay by installments. So we use some financial services. So we will help you to join us by paying paying by installments, and you will still you will have the opportunity still to lock the price by paying $49 right now. So you can scan this QR code. Again, the number of students in the group is limited because we want to pay attention to all the students, and that's why you can join us right now, and you can scan this QR code if you want to pay once a time the full amount, and this QR code, and you can use this QR code if you want just if you have more questions, if you want to pay by installments, or if you want to get our consultation as for our other courses, or whenever like somebody of you ask us about Python, you can start with this course too. If you never experienced before, it's a good start in IT. So we can also help with this too. Okay. It's customer service 24/7 when we sign up. If you sign up right now, we will contact you tomorrow or today. It depends of how many. I think that it will be tomorrow. But if you want to join us right now, you can just, as I said, scan QR code and make a note that you wanna join us right now. So we will help you with this too. We have a customer service 24/7, so don't worry about that. Okay. Okay, I didn't see any questions. Leslie, what is your company called that's hosting this program? Okay, yeah, I know that there are a lot of people who joined a little bit later. So let me tell you more about our company again. So our company calls Black Screen School, but our project of the IT school calls programming in Silicon Valley. It calls like PASV for English. So this Black Screen is for English speaking students. But our company was founded in 2016 in California, and most of our courses were for Russian speaking people, for Russian speaking students who found the jobs in America. So we decided, why American, like English speaking students, English speaking people can find good jobs in America. So that's why this project was born for you guys. So we have 3,500 graduates. We have 25,000 plus online students from all over the world. And our instructors and assistants work in companies in the USA, Canada, and Europe. And all our teachers are experienced. So, and most of them are still working. They're not just like teaching. So you will get knowledge not just from like teacher. You will get knowledge from people who are working in this field, for getting like all the information. from experienced teachers. And training takes place in small groups. So to ensure personalized attention, Barlos said, I joined late. No worries, we will send you the recording, the recorded video. Yeah, it will, the course starts February 3rd. And you can also find other reviews on our website, on our YouTube. You'll find a lot of other reviews from our students. And there is the companies where our graduates have been hired by these companies. So you can be part of this graduates too. Yeah, I can provide you the link to our YouTube channel, so you can wait a minute. Yeah, I will send you the link. To our chat. Let me do this. So here's our YouTube channel. So you can look at our reviews, our students. You can find like a lot of them in there. And let me tell you again about our timeline of the course. So February 3rd is the day when you'll start our 6-month journey, our 6-month course. And then you will learn and practice 3 times a week. There will be live sessions, and if you can participate, you will get recording lessons. Then you will get internship. That is a project, as we mentioned before. So you will get your own project, so where you can, which you can add to your resume. And our career coach will help you to improve your online presence, prepare you for upcoming job interviews, to build your resume, and support you like step by step. So is this a corporate website or a training company? Irina already answered that it's Tech Academy in California. Thank you, Irina. All right, and if you're not experienced at all, we would recommend you to start with Python. It costs $999. If you're already well known with Python, you can join to our machine learning course. It costs $6,999, but today you can pay. But today we can. You will get special offer, so it will be 1,000 less. It will be $5,999. So you can follow this QR code and lock in the discount for $49, or pay the full amount. If you want to pay by installments, you can follow this QR code, and we will guide you how you can pay by installments, or we can also consult you about all other questions. All right, would I need my laptop, or can this be done mobile? With no prior history of coding, would the program take more than 6 months? would I need my laptop or can this be done mobile? I think on this question, as for mobile or laptop, it would better Akko answers, because as I know, there's like necessary to use laptop, right, Akko?
Yes, I think you will need a laptop, but even a simple basic laptop, which can cost like $100 or $200, could do the work. You don't need to buy expensive machines, or even a tablet could work for you.
Thank you. And as for the rest of the questions, so with no prior history of coding, would the program take more than 6 months? So look, our program takes 6 months, and like we will give you all necessary information. So we'll give like 50% of responsibility will be on you. So we will give you like 50% of knowledges, and you will have 50% of your own responsibilities. So if you join all our classes, if you've done all homework in time, you will graduate in 6 months, and moreover, you can find a job in 6 months. If you start working hard and following all our instructions, you might be done even earlier. It's up to you. It's everything on you. Like we just help you and support and give you all of like knowledges, practice, projects, and you can finish even earlier. If we had a lot of students here, of course we had students who didn't finish in time, but we also had students who were like so motivated that they finished like even earlier. So everything like it's up to you. All right, so I don't see any questions right now. I sent our YouTube in our chat, so you can copy and follow the link and look through the reviews of our students. And don't forget to scan this QR code so we can consult you if you want to pay by installments, or if you have any other questions as for our courses. We would be happy to help you. I have a laptop. I just work during the day of aerospace, so I barely have any time. My free time are after 11 p.m. Would this still be possible to graduate if I'm always late to the courses? Again, you will get the recordings, lessons. So if you have the opportunity to watch the lessons, they usually like for 1 hour lessons. So if you have 1 hour after your job or during your day, and you can spend some time after the job on doing homework, why not? I think that it's possible. Okay, what do you think? If, for example, people are usually working like during the day, and how many hours do they have to spend on doing the homework, on watching material, like learning material?
Well, it depends, but depending on each situation, there were times that I was waking up around 2 hours earlier to get my lesson, and sometimes I will have to stay late to finish a project. So depending on your work time, it's a good advice to set aside 1 to 2 hours. Also, you may print part of the instruction, and in your lunchtime or your free time, go over them. But remember, the most important thing is doing. Even if you are in a, let's say, metro or bus, if you have your hands on the keyboard and do the coding, then we can say your hands learn that. When you have that and you overcome the fear of programming, then after that, it will be much easier. But it's important to commit a minimum time, preferably every single day, if not at least every other day. That will help you. And If it caught your interest, then you will be really immersed in that and you'll find every moment to learn more. So it really depends on you. There's no one size fit all. But on average, if you have 3 classes a day, 1 hour each class, and you spend half an hour or 15 minutes reviewing it, that will be good. And then you might set aside sometimes in the weekend to really do the project.
All
Hope I
right.
answer your question.
Yeah. So I think that we are good for today. I thank you, Ako, for your information, and thank you everybody for the questions. Okay.
Okay. Thank you, everyone. Have a good rest of your night.
Yeah. Bye-bye.